metals. Infrared is just outside the visible spectrum of what humans can see. Actually, the mirrors are not solid gold, they are made of beryllium. To function correctly, the Webb telescope needs to be kept cool. It does that thanks to a 5-layer sun shield the size of a tennis court. This mechanism was folded up when Webb launched on Christmas Day, but less than 2 weeks later, the extremely thin layers of the shield were successfully deployed. Without the shield, the immense heat from the sun would overwhelm the telescope's sensors. The side facing the sun will experience about 260 degrees Fahrenheit, while the other side will be chilled to some 370 degrees below zero, a nearly 600-degree difference. The sun shield gives Webb the equivalent sun protection factor, or SPF, of 1 million. One thing that makes scientists nervous about the Webb telescope is that they won't be able to fix any issues that arise, both during the launch and operation. For comparison, in Hubble's lifetime, 5 space shuttle crews have made service calls to correct the telescope's initial blurry vision and perform maintenance and upgrades. But that is because the Hubble is only 340 miles away. The Webb telescope is much farther away, nearly 1 million miles away. This is far beyond the reach of spacewalking repair crews, so NASA only got one chance to get it right. However, if the proper technology is developed, scientists could someday send a robot to refuel Webb, extending its life. Speaking of fuel, NASA initially thought the telescope would last only 10 years, but thanks to an efficient launch, there is enough fuel left to power the JWST for 20 years. For now, scientists are eagerly awaiting Webb's first photos, which will arrive this summer. After that, the JWST will settle down to work. It will help to investigate the nature of dark energy in the universe and understand the nature of these very old objects. It will also help to search if there is another Earth out there among the distant exoplanets that litter the universe. Interestingly, the JWST has started proving its worth almost $10 billion even before taking its first photos. Northrop Grumman, which built the telescope's mirrors, had to cover new ground because a precise mirror had never been created. The technology the company invented is now being used by eye surgeons. They also developed stuff on the computer level. The company made huge advances in understanding how to deploy big things, like how to take a giant sun shield the size of a tennis court and fold it up neatly and deploy it. Now, when astronomers try to see the edge of the universe with the JWST, what will they see? Humans have always been interested in what surrounds us, but traveling across the universe isn't just traveling through space, but through time as well. But before we get on, we need to establish something, the dimension of the universe, because to find the edge, we should first know the dimensions of the universe. Our universe is expected to be 13.772 billion years old, making it quite old. So how big is our universe really? Scientists today estimate it to be 28.5 gigaparsecs in width. Getting a grasp of how big that figure is requires some basics of astronomical units. How large is a parsec? To understand how a parsec is defined, you should first know what an astronomical unit, AU, is. 1 AU is essentially the average distance between the Sun and the Earth, approximately 150 million kilometers. So a parsec is defined as the longest length of a triangle whose shortest side is 1 AU and which subtends an angle of 1 arcsecond at the opposite vertex. If you calculate further, you will see that 1 parsec equals 3.26 light years, or the distance light travels in 1 year, which is about 9,460,000,000,000 kilometers. And we are talking about 28 gigaparsecs here, which is 93 billion light years. That is 879,780